Alrighty, tighty. Oh, baby, happy Monday. Stock market crash. Everything's going to hell. Okay, it's going to be fine. We're going to be fine. Just going to get a little sick for a while. Oh, Wuhan. Okay, so from the 403 to the HHAZ. Mr. Nelson in the house. Looking forward to finish talking about function transformation. So, in our previous videos, we have looked at what A, B, H, and K do for us. Each causes a transformation. And let me recap these for you. So we know that A is our vertical stretch. And it's by a factor of the absolute value of A. When A is negative, we have a reflection in the x-axis, and yeah, so when when the absolute value of A, just the value of A, doesn't matter if it's negative or positive, when the absolute value is greater than 1, we get a stretch, and then when the absolute value of A is a fraction, we get a compression along the y-axis. Okay, and A's evil twin is B, and B kind of behaves in an opposite manner, okay? And so B is going to be horizontal stretch, okay, along the x-axis, where this was along the y-axis, by a factor of 1 divided by the absolute value of B. So if B is 2, 1 divided by 2, we're going to actually be shrinking by a half. So it kind of behaves in an inverse way to A. However, when it's negative, we still get a reflection, but that reflection is in the y-axis. So we're reflecting along the y-axis versus A, which we're reflecting x-axis. And so when B is greater than 1, 1 divided by B means we're going to actually get a compression along the x-axis. So it behaves opposite to A. And then when B is a fraction, 1 divided by a fraction is going to be a number bigger than 1. So we're going to get a stretch. Okay, that's A and B. A, we're going to multiply our y-coordinates by A to get the stretch factor. And for B, we're going to multiply our x-coordinates by 1 divided by the absolute value of B. So we'll see what that kind of looks like. And then we have our horizontal and vertical, start with the vertical, translations or shifts. So K is just a direct vertical shift. If K is positive, we're going up. If K is negative, we're going down. And then K's evil twin, cousin, uncle, brother, is H. And H is a horizontal shift. And H, like its baby mama B, behaves in the opposite. So if I have a negative H, it means I'm moving to positive X. And if I have a positive H here, I'm moving negative X. Horizontal shift / translation. So there it is. That's everything. That's all of our function transformations. So let's actually see what these look like in practice. I am going to, for ease, I'm just going to use my quadratic function. So I'm going to say f of x is equal to x squared. That's going to make an easy table of values for me to make. And let me make said table of values. I am going to just go from -1 to positive, or so -2 to positive 2. That's going to give me 4, 1, 0, 1, 4. When I put in the x's, that's going to be my f of x or my y. Okay, so that's there. I'm going to erase this because I need the space. So So let's say that I have now a transformation function. We'll call this g of x, and I don't know what g of x is as a function, but I know how it relates to f of x. And I'm going to say that g of x is equal to 2f of x minus 3 plus 2. Okay, this will be my first one. So I look here, and the first thing I'm going to want to do is identify what all these numbers represent. So I'll look here, I've got a number in front of my function f. That's going to be my a. So I know that a is 2. And then I look in here, I don't have any number in front of my x, multiplying x, but I do have an h of positive 3. That's the opposite. And I have a k of 2. So here is the important rule for combinations of function transformations. We always, I'm going to write it nice and big, apply A and B transformations first. And then I do the adding and subtracting of my shift second. H and K come second, okay? Big and bold so that you don't forget it. I'm always going to apply my A and my B first. So if I have a function stretch and a shift, I'm going to do the stretch first. I'm going to multiply all my y coordinates, in this case, because A and K are y. I'm going to multiply all my y by 2, and then I'm going to add the 2 here. Okay, so, let's now build our new table of values. So, my new table of values is going to be right here, and it's going to be x and g of x. So, let's do my y's first. I don't have a negative a, so there's no reflection, but I'm going to multiply all of my function outputs, my y's, my f of x's, I'm going to multiply all of them by 2, and then I'm going to add 2, because these are my y coordinate manipulations. So, my first f is 4, 4 times 2 is 8, plus 2 is 10. 1 times 2 is 2, plus 2 is 4. 0 times 2 is 0, plus 2 is 2. 1 times 2, 4, 10. Okay. And now I can go ahead and do my x transformations. I don't have any b, so I can go straight and just add 3 to each x. That's what happens with h. We just add it to the x. So I get negative 2. Negative 2 becomes plus 3, becomes 1. Negative 1 plus 3 is 2. 3, 4, and 5. So this is my new function, and if I were to graph the original, my original would go from 4 at negative 2 to 4 at 2. And then my new function, it's going to start, well, it's going to be way up here. I'm going to just do a little arrow. So it's going to start at x is 1, 10. It's going to come down and bottom out at 2 and go back up. So my vertex here will be at 3 and 2. So that is going to be my bottom versus 0, 0 on the original. And as we can see, we shifted it 3 to the right and then 2 up. That's what we did to our vertex, just like when we learned quadratics. So it's not so bad, is it? Let's do another transformation of the same function. Because if we can transform one function, we can transform all of them. So I'm going to do now, it's going to be equal to negative f 2 x plus 1 minus 2. Okay? So the first thing I'm going to want to do is identify what all of my letters are in this function. So I got an a. A is negative 1. The absolute value of a is 1, so I'm actually not going to be stretching or compressing it, but I will be reflecting it. And I have a b of 2, and I have an h of negative 1, and a k of negative 2. K, H, B, A. So the only thing I need to really make note of here is this is going to require a stretch by a factor of 1 over the absolute value of 2, or 0.5. So I'm actually going to multiply all of my, b is x coordinates by 0.5, and then I'm going to subtract 1. Then I'm going to move it left by 1. So let's make our new table of values. I've got my x's and my g of x's. And I can start with, I'll start with my y coordinates. I'm going to multiply each y by -1 to get that reflection. So I'm going to multiply each y by -1, and then I'm going to subtract 2. And that's going to be what causes my reflection in the x-axis, is applying that -1. So 4 times -1 is -4 minus 2, -6. -1 minus 2, -3. 0 minus 2, -2. 1 minus 1, -1 minus 2, -3, -6. We have symmetry here. We didn't change the symmetry on my quadratic. Now let's do my x coordinates. So b was 2, so I'm actually doing a compression. It's 1 over, it's the inverse. So I'm going to multiply each x by 0.5. I'm applying my a and my b's first. I'm going to multiply each x by 0.5, and then I'm going to subtract 1. So -2 times 0.5 is -1, and then -1 is 0. -1 times 0.5 is -0.5. -0.5 minus 1 is -3/2. 0 times -0.5 is 0, minus 1 is -1. 1 times 0.5 is 0.5, minus 1 is -0.5. 2 times 0.5 is 1, minus 1 is 0. Okay? Whoops, this can't be right. -2 times 1/2 is -1, minus 1, that should be -2, my bad. This makes more sense. So there's my new function, and again, I can graph my original. My original goes from -2, 4 to 2, 4, there. And my new one, at -2, I'm going to be at -6. At -3/2, I'm going to be at -3. At -1, I'm going to be at -2. At -0.5, I'm going to be at -3. And at 0, I'm going to be at -6. So this graph is going to look something like this, where we have a reflection in the x-axis. We have not stretched it. So my original was, actually we have stretched it slightly, so that's because of my b. So when we start combining a's and b's, it gets a little funky, but this is essentially what my new graph would look like. We can see that we shifted it over by 1, and we dropped it by -2. My original function was 4y, it went from -2 to 2, but we applied a stretch of 0.5, so we actually made it half as wide. And if we go from -2 to 0, that's half of 4. So we have made it half as wide, and in doing so, we also made it a little bit taller. But let me check my numbers. I'm confusing myself here. 4 times -1 is -2. Yeah. So sometimes A and B transformations can kind of look funky, but this is what it looks like. We did it correctly. So let's do one more transformation. And this time I'm going to really throw it all together here. So we're going to get, we'll do -1/2 f of 1/2 x plus 2 minus 1. We've got everything here, okay? So let's write down what we know. We know that A is -1/2. So I'm going to get a reflection and a shrinking vertically. It's going to reflect, it's going to go down, and we're going to shrink it a bit. That's what that's going to do. B is also a half, so I know that I'm going to get a reflection by 1 over 0.5 or a half, 1 divided by B, the absolute value of B. So I'm actually going to apply a stretch factor of 2 to all my x coordinates. And then H is -2, and K is -1. H is always the opposite of whatever sign we see there. So now that I have that, I can go through and make my new table of values. And remembering that I'm always going to apply A and B before I apply H and K. So let's do A first. I'm going to take all of my y's, A applies to y's, my g of x's, g of x, f of x, y, they're all the same thing. Okay, this is my output, y is an output. So I'm going to multiply each by -1/2, and then I'm going to subtract 1. So 4 times -1/2 is -2, minus 1 is -3. 1 times -1/2 is -1/2, minus 1 is -3/2. 0 times -1/2 minus 1 is -1. 1 times -1/2 is -0.5, minus 1 is -3/2. 4 times -1/2 is -2 minus 1 is 3. Okay, so I applied my A, and then I subtracted my K. Okay, I did my stretch and then my shift. And I'm going to do the same thing with my B and my H on my x coordinate. So, -2 times 2 is -4. -4 minus 2 is -6. -1 times 2 is -2, minus 2, -4. 0 times 2 is 0, minus 2 is -2. 1 times 2 is 2, minus 2 is 0. 2 times 2 is 4, minus 2 is 2. And now I can just go ahead and graph my functions here. My original goes -2, 4 to 2, 4. And my transformation goes from x is negative to 6. So we were at -2 originally, so we're actually going to be way out here. -6, 3. I'm going to be at -4, -3/2. Whoops. -6 minus 3. So we're way out here. And then -4, -3/2, somewhere in that range. -2, -1, 0. At x is equal to 0, I'm at at 0. Okay, so I'm kind of not. Well, that's -2, -4, so I'm probably way over here. That's just why I'm getting confused. And at 0, I'm at -3/2. Okay, so I start coming down again. Right, okay, so that's where I should be, right there. So that's my peak right there, at -2, -1. And then at 2, I'm at -3. So my transform function, after much deliberation, looks something like that. And I should find that it's twice as wide because we applied a stretch by a factor of 2 along the x-axis. So my original was 4 long. Now it goes from -6 to 2, it's 8 wide. So yes, that is in fact true. It should be half as tall. And I look at so I was originally 8 tall, and now I'm 6 tall. Sorry, I'm 2 tall. So I went from 4 tall, and now I go from -1 to -3. So I go from -1 to -3. Yes, I'm half as high, half as tall now. And I should find that my original vertex was 0, 0, and based on my H and K, I should have moved it left 2 and I have a peak at -2, -1, and down 1. And my peak is, so basically my vertex now is -2, -1. And that links up with this perfectly. So that's all we do with function transformations. We apply the A's and the B's first, and the big thing to remember is B is an inverse to the A, and H is also inverse to whatever we see there. And we're always applying A and B first, and then H and K second. Thank you for watching. Have a great week in this pandemic.